Hello and welcome. In this video tutorial, we're going to take a look at Skills Practice 1.3, Speed Problems. Remember to pause or rewind the video as you need to. Let's begin. Read along with me at the top. To determine the speed of an object, you need to know the distance traveled and the time taken to travel that distance. However, by rearranging the formula for speed, that is v equals d over t, you can also determine the distance traveled and the time it took for the object to travel that distance if you know the speed, for example. A couple of things that you should know. One, if you're looking for speed, that measures how fast. Distance is measuring how far, and time is measuring how long. Okay, now where are we coming up with these three equations here? Let's take a look at the main speed equation. V equals d over t. Now, if I'm solving for speed, it's already isolated. I simply plug in distance and divide it by time. But let's say I'm solving for distance. Well, if I'm solving for distance, then I need to remember to get rid of the divided time. Well, what's the opposite of dividing by time? Multiplying by time. So I multiply both sides by time, and I get distance is equal to velocity times time. So far I've got one equation. I've got the same equation, but rewritten for distance. And then if I look at it one more time, and I'm trying to solve for time, which is in the denominator of the fraction, one of the things you might remember is that a trick we learned to solve for the denominator of a fraction, we affectionately call it the switcheroo, and we get time is equal to distance divided by speed. So we have three possible equations, and they're all summarized right here. It's good to know how to get to any of those equations from the main speed equation right here. Let's take a look. Now, the first time we read is for concept. Now, in this particular problem set, your concept is going to be constant speed related simply because we're only given one speed in every single problem. However, the first read of a problem is typically done to help you figure out the concept. The second read is for information. You're reading for content. You're annotating the question. And we have to be able to determine one of these three variables. We have to list those three variables and figure out what they are. Let's take a look at number one. A bicyclist travels 60 kilometers in 3.5 hours. What is the bicyclist's average speed? Well, if I see kilometers, that is a unit of distance. So I'm going to write a D above 60 kilometers. And then 3.5 hours, well, that's a measure of time, so I'm going to write a T above that. And then average speed I'm looking for is V equals question mark. So in my problem-solving box here, in the looking for box, I'm going to write V equals question mark because I'm looking for the speed. The givens, well, what am I given? I am given that distance is 60 kilometers. And I'm given time is 3.5 hours. The relationship I use, I write down the main equation, V equals D over T. That's the main equation. I go to my solutions box here and I copy down that same equation to start with. And then I take a look. What am I solving for? Well, I'm looking for V. It's already solved for V, so I don't need to rearrange anything. I can simply plug in these numbers for D and T. And let's get a calculation going on. And it's going to be 60 kilometers divided by 3.5 hours. Pause the video and run this calculation yourself and see if you can get the answer for the average speed. Okay, if you put that in your calculator, you should be getting approximately 17 kilometers per hour. Now, in question 2, 3, 4, 5, 6, 7, 8, 9, and 10, we're going to be filling out these problem-solving boxes to help organize our work. So let's go ahead and number them off. This is going to be for question 2, question 3, question 4. Go to the second page. This one's going to be 5, 6, 7. And on the last page, this is going to be 8, 9, and 10. Okay, let's take a look at number 2. What is the average speed, so V is the question mark, of a car that traveled 300 miles, that is a distance, in 5.5 hours? Well, there's the time. We're looking for V, that was the question mark. You were given distance and you were given time. The distance was 300 miles. And the time was 5.5 hours. We start with the main equation, V equals D over T. We write down that main equation in the solutions box, and you have to ask yourself, do I need to rearrange it and solve it for another variable? I do not, because I'm looking for V. So plugging into this, we're going to take 300 miles, divide that by 5.5 hours, and the average speed, go ahead and pause the video and try to make this calculation yourself. Okay, we should be getting about 54.5 miles per hour. And we're going to write miles per hour as MI/H, not MPH. You could have, of course, rounded this up to 55 miles per hour. That would have been fine. Number 3. Let's annotate the question here. How much time, well, we're looking for time this time, would it take for the sound of thunder to travel 1,500 meters, there's distance, at a speed of almost 330 meters per second? There's the speed. So in the problem-solving box for number 3, we're looking for time. So we're going to write time equals question mark. We were given distance and we were given speed. Distance was 1,500 meters and speed was 330 meters per second. Start with the main equation in the relationship box that basically tells you a starting point. We copy that down and then we ask ourselves, do we need to rearrange the equation? Yes, we do, because we're looking for time, and time is in the denominator. So I can use the switcheroo to rearrange this and solve it for t. And t, time, is equal to distance divided by the speed. And I will take 1,500 meters divided by 330 seconds. Pause the video and try to run this calculation yourself. Okay, if you did this correctly, you should be coming up with about 4.5 seconds. Number 4. Number 4 says, how much time would it take an airplane to reach its destination if its average speed were 790 kilometers per hour that will be speed, and a distance of 4,700 kilometers. That would be distance. Okay, so we're looking for time. We're given the speed was 790 kilometers per hour. We're given the distance was 4,700 kilometers. V equals D divided by T is the relationship. And I'm going to split the solution box in half because I really have a part A and a part B in this question. Part A is finding the time. Part B is changing that speed into miles per hour instead of kilometers per hour. But for part A, we're going to start by writing the main equation. And again, we're solving for time. So again, we're going to use the switcheroo. Switcheroo only works if we're solving for the denominator of the fraction. Keep that in mind. So time is equal to distance divided by velocity. Time is equal to 4,700 kilometers divided by 790 kilometers per hour. And that gets you about 5.95 hours, almost 6 hours. How do we convert this into miles per hour? Well, we need to know that there are this is the conversion, 1.609 kilometers in 1 mile. So we're going to start off with the speed was 790 kilometers per hour. Hour can stay as is because we want to turn this from kilometers per hour to miles per hour. We are going to multiply by a conversion factor of kilometers converting into miles. Now we're going to be in miles per hour. Notice kilometers cancels. And the conversion here is that 1 mile is 1.609 kilometers. So the math you're actually doing is 790 divided by 1.609. 790 divided by 1.609. It's approximately about 491 miles per hour. Roughly. Number 5. How far can a person run in 15 minutes if he or she runs at an average speed of 16 kilometers per hour? Remember to convert minutes into hours. Well, the first thing we notice is that 15 minutes, well, that would be the time. This is the average speed. And we're looking for how far, so we're looking for distance in this one. But let's take a look at number 5. In the problem-solving box, we're going to label D as our looking for variable. That's what we're looking for. That's our unknown. The knowns would be V. That's going to be 16 kilometers per hour. And T, which is 15 minutes. Now, what we need to remember to do is we need to remember to change 15 minutes into hours. So I'm going to write minutes down here and hours up here. And of course, there are 60 minutes in 1 hour. And so the math we're doing is actually 15 divided by 60. And if we do the 15 divided by 60, we get approximately a quarter of an hour, or 0.25 hours. The relationship we're using is V equals D over T. Copy that again over here. But this time, we need to solve it. So to solve for distance, you need to multiply both sides by time. And distance equals speed times time. Speed would be 16 kilometers per hour times 0.25 hours. Notice hours will cancel. Go ahead and pause the video and try the calculation yourself. Okay, I'm not sure we needed a calculator for this one. 0.25 is a quarter. A quarter of 16 would be 4 kilometers specifically. Number 6. In problem 5, what is the runner's distance in miles? Okay, so we're looking for distance, but this time in miles. Okay, we're given the distance in kilometers, so 4 kilometers. Okay, there are 1.609 kilometers in every mile. We need that information. And so we're going to take the 4 kilometers we're starting with, and we're just going to do unit conversion. Number 6 is simply a unit conversion problem. So if I have kilometers here, I'm going to recopy it down here so that it can cancel, and I'm trying to get to miles. The conversion is 1 mile for every 1.609 kilometers. So the math that we are doing here would be 4 times 1 divided by 1.609. Go ahead and pause the video and see if you're able to get this calculation correct. Okay, we should have gotten about 2.5 miles. Number 7. It says how a snail can move approximately 0.30 meters per minute. Well, that's going to be your speed. How many meters, that's the distance, is the question mark, can the snail cover in 15 minutes? That would be the time. We go to the 7th problem-solving box. We're looking for distance. The speed was 0.30 meters per minute. The time was 15 minutes. So we're looking for V equals D over T. And if you remember, we multiplied both sides by time and we got distance is equal to speed times time. So distance is equal to 0.30 meters per minute times 15 minutes. You can see how minutes cancels. Go ahead and take a second to put that in your calculator, pause the video, and see if you can get this one correct. Multiplying 0.30 times 15, you should get 4.5 meters. Number 8. You know that there are 1.609 meters in a mile. And if you don't know, now you do. And there are also, a mile, there are 5,280 feet. Use these to answer the following. How many centimeters equals 1 inch? Then, what is the speed of the snail problem in inches per minute? Okay, here we go. We're looking for how many centimeters equal 1 inch. Okay, so there's the first part. We're doing a conversion. So how many centimeters equals 1 inch? But we're also looking for the speed of the snail in inches per minute. Remember, it was in the speed was originally given to us in meters per minute. So we're just going to do a conversion from meters to inches. Okay, what are we given? Well, we're given the fact that there are 1.609 meters in a mile. 1,600 meters in 1 mile, and that there are 5,280 feet in 1 mile. So we have that. And what we're basically going to do, we're given the speed is 0.30 meters per minute, but we're going to convert that into inches per minute. You'll see that in a second. Okay, so we'll split the box in half. Part A on top, part B on bottom. Part A, we're trying to convert between, let me see, 1 inch. So we'll start with 1 inch. And the first thing we're going to do is we're going to multiply by the fact that there are 12 inches in 1 foot. Then what we'll do is we'll multiply by the fact that there are 5,280 feet in 1 mile. Lastly, we're going to multiply by the fact that in 1 mile, there are 1,609 meters. And then finally, there are, in 1 meter, there are 100, I'm sorry. Let me back that up. Yes, I was right. So in 1 meter, there are 100 centimeters. There we go. So meters cancels, miles cancels, feet cancels, inches cancels, and we're converting into centimeters. Mathematically, what are we doing? We are multiplying 1 times 1 times 1 times 1 times 1609 times 100. And it's going to be 160900 over, if I multiply 12 times 5,280, I get 63,360. And if I divide those two, I get 2.54 centimeters. That is the conversion between inches and centimeters. There are 2.54 centimeters in every 1 inch. Okay, so using that information, there are 1 inch is 2.54 centimeters. This is going to be a conversion we're going to use various points in the year. So we're going to take the velocity that we were given, 0.30 meters in per minute, and we're going to multiply this by a conversion factor of, and I'm going to change the 30 centimeters into, 0.30 meters is going to be 30 centimeters. So I'm going to change it to centimeters. And we know that there are 2.54 centimeters in 1 inch. So dividing those two, we get about 11.8 inches per minute. The snail moves almost 1 foot per minute. Number 9. Calculate the average speed, so we're looking for V, of a car stuck in traffic that drives 12 kilometers in 2 hours. Okay, we're looking for V, the average speed. We were given a distance. We were given a time. The distance was 12 kilometers. The time was 2 hours. Again, we're using v equals d over t. I do not need to rearrange the equation as I am looking for speed. So take your 12 kilometers divided by the 2 hours, and the average speed would be 6 kilometers per hour. And in question number 10, it said, how long? Well, how long is time? How long would it take to swim across a lake that is 900 meters, that's the distance, if you swim at 1.5 meters per second? That would be speed. We want the answers in seconds, and then we'll convert it to minutes. So we're looking for time. Distance would be 900 meters. Velocity would be 1.5 meters per second. Speed equals distance over time. I'm going to throw this as a two-parter. Separate this a little bit. This is going to be part A. This is going to be part B. So V equals distance over time. Time equals distance over speed, which would be 900 meters divided by 1.5 meters per second. And so if we divide these two, the meter is going to cancel, leaving you with a time in seconds. Pause the video, try to make the calculation yourself. Okay, if you got this correct, you should have gotten 600 seconds. And lastly, we need to convert it to minutes. So to convert seconds into minutes, that's what we're trying to do. We're going to take our 600 seconds and we're going to multiply by the conversion factor that says there are 1 minute in 60 seconds. Well, seconds are going to cancel. When we divide 600 by 60, we're left with 10, specifically 10 minutes. I hope you found this video tutorial helpful. Again, remember to pause and rewind it as necessary.